The software industry has been around for a while now, dating back to the 1940s, solving problems for government and industry. A revolution began in the 1950s with the introduction of the Fortran programming language, and later in the 1960s, the introduction of COBOL, and then the introduction of the first object-oriented language, Simula. The revolution continued through the 20th century with the introduction of many new languages, some that are still vibrant today. In all of that time, providing solutions to business and government, the solutions developed by the software industry began to look repetitive. The ability to take advantage of that repetitive nature was recognized and discussed in the now famous book by Gamma et al., the Gang of Four book. What was discovered is that software, independent of the language that's used for implementation, provides solutions repetitively to the same problems. If those problems could be described in a language-independent manner, then they could be used by software architects to more rapidly solve these recurring problems. So a design pattern became a recipe for solving some recurring problem in software. Arguably, design patterns have increased productivity and decreased development time by providing recipes for the solution of some common problem, alleviating the need for the developer to reinvent the solution. Because design patterns are language independent, they give us a way of discussing a problem regardless of our language expertise. And now a simple internet search will uncover libraries of design patterns that can be applied to software solutions. So there are many benefits to using a design pattern. Exploiting prior knowledge so that a solution that is known to work for an encountered problem that we're trying to solve in software, that solution can be applied to our project regardless of the programming language that was used in the initial implementation of the solution. The design pattern specifies the structure and interface of the objects, but does so in a language-independent manner. So again, regardless of the language we choose to use to implement the design pattern, the object description in the design pattern remains generic, regardless of the programming language with which we choose to implement the solution. The design pattern description of the objects and their interfaces remains language independent. So this greatly increases the reusability of the solution as it's defined in the design pattern. Now, there are three general categories of design patterns. Patterns that control the creation of objects, like the singleton pattern. There are structural patterns, and there are behavioral patterns like the observer pattern. We're going to discuss both the singleton and the observer pattern and leave the rest for individual study. The singleton pattern is a powerful pattern that allows us to create and manage the instance of an object, ensuring that there is only one instance of that object within our application. This is an excellent design pattern choice for classes that manage resources such as a database connection. In this design pattern, which is a creational pattern because it controls the creation of the object, this pattern defines a class with a private variable instance, a constructor, and a public function getInstance that returns a handle to the one and only object of this type within the system. And here's a sample PHP code for the singleton pattern. The observer pattern, also known as the publish-subscribe pattern, allows a single object to notify multiple other objects of some change in state. The subject object in this pattern has two public methods, add observer and remove observer. And as their name suggests, these methods manage the observers or subscribers who are interested in the subject's change of state. The subject also contains a private notify observers method, and this method is responsible for sending notification of some change of state to all of the observers that have registered with the object. The observer class has a single public method, handle notification, which is called by the subject's notify observers method. So when some change of state occurs in the subject's notify observers method will iterate through some list of observers and call handle notification on each of those registered observer objects. So let's go look at some code.